Welcome to Monday's Homework Help, brought to you by me, sponsored by me. Yep. Okay, so here we go. Let me bring it up. Ta-da! All right. So this is why I did the little mini lesson at the end of the day, because you have to do it on your homework. So it says, topic, recognizing functions. Identify which of the following representations are functions. If the representation is not a function, state how you would fix it so it was. Shouldn't that say so it is? If the representation is not a function, state how you would fix it so it is. Anyways, whatever, not an English teacher. Moving on. The first one. So remember, functions. Let me write it again. Function. We'll say x value. Every x value can only have one y value. Okay? Remember, x's have to be exclusive. All right. Let me see if I can just fix that there. So the first one, this is similar to ones we did in class. So I have the point when x is 4, y is -1. When x is 3, y is -6. When x is 2, y is -1. When x is 1, y is 2. 0 and 4, 2 and 5. All right, so do I have any repeated x values? Yes. Let me do this. We got x equals 2 and x equals 2. All right, I want to be done highlighting now. There, okay. So when x equals 2, y equals -1. But also when x equals 2, y equals 5. No. No. X equals 2 can only have one y value. It either has to be -1 or 5. It cannot be both. So this is not a function. Function. And then how can we fix it? You can change to a different number. So like instead of 2, 5, this could be any x value we have not used. 4, 3, 2, 1, 0. Okay. 6, 5. Okay, if we change it to that, then it is a function. So you have to change your x value to any x value that has not already been used. So anything except 4, 3, 2, 1, or 0. It could be any other number, and it would be a function. All right, number 2. The number of calories you have burned since midnight at any time during the day. Okay, so this is making you think about real life a little bit. So you're always burning calories. Science. Your body is always burning calories, always. Even if you're just laying in bed being a lump, you're burning calories, okay? Not as much as if you're walking around or doing pretty much anything else, but you are burning calories. All right, so let's make a little table. We'll do time and we'll do calories. All right, so at midnight, you've burned 5 calories. At 1 a.m., you've burned, I don't know, 3 more. So now you've burned 8. This is not how calories work. Don't pull this into science. At 2 a.m., you've now burned 11. Okay, and so on and so forth. So your x values are never going to be repeated, right? You're going from midnight to 11 p.m. So your time is never going to be repeated. This is your x values are going to be 12, 1, 2, 3, 4, 5, 6, all the way down to 11. Okay? Hopefully that makes sense. So you don't have any repeated x values. So this one is a function. All right, the graphs. I'm only going to do one of the graphs. Which one am I going to do? I'll do number 3. We'll just keep going in order. But then I'm going to make you do 5 and 6 on your own. So number 3, let me see if I can just get a line real quick. Theoretically a straight line. There we go. Okay. So remember, if you're given a graph, you don't have to, but you can use the vertical line test. So to be a function, it can only intersect my graph at one point. So as I drag this line along, if it only intersects it at one point, we're good. So like there, bam. We're only intersecting it at one time. Bam. They're only intersecting at one time. Actually, I can just, I'll just make a lot of those. Can I find? All right, so then here's another vertical line. Okay, only intersecting the graph at one point. There's another one, only intersecting the graph at one point. All right, you could do them, you can go all the way through the graph. So this one is a function. All right, because it passes the vertical line test. So every x value only has one y value. For instance, what's an easy one to do? All right, when x is -1, so right here, y is 2, and that's it, right? There's nothing else on this line. So it is a function. All right, the rest, I'm going to let you try on your own. Let's go down to here, 7 through 12. All right, so it says, comparing rates of change in linear, quadratic, and exponential functions. I might just go through all of these with you. All right, let's see. So number 7. Oh, sorry. The graph at the right shows a time versus distance graph of 2 cars traveling in the same direction along the freeway. Okay, so if you have time versus distance, then time is going to be your x value. So this is time, and this is going to be distance. All right. Which car has the cruise control on? How do you know? So you have car A and car B. Which one has the cruise control on? Car A. Because car A is a straight line. It has a constant rate, right? It's increasing at a constant rate. So cruise control on a car, if you probably none of you have driven yet. Maybe you have. You can flip a switch and it's on cruise control, and so that means your car will just go whatever speed you pick. So it'll go 25 miles per hour, and it'll just stay on that. That's what being on cruise control means. All right, so it's staying the same. It's driving at a constant rate. All right, so car A, because it has a constant rate. Which car is accelerating? How do you know? Car B. Okay, so let's look at car B. So car A, we're always going the same speed. All right, remember this is distance, not speed. So we're always going the same speed. Car B, on the other hand, kind of like our tortoise, starting out slow, but then it increases pretty quickly. How do you know? So then you would also explain how you know. Because the rate of change is not constant, because the rate is increasing, something like that. Okay. Number 9, identify the interval in figure 1 where car A seems to be going faster than car B. Okay, keyword there, seems. That means you don't have to exactly figure it out, you're eyeballing it. So wherever you think, oh, wait, hold on, let's backtrack. Going faster. Okay, so this is, let me just label it. This is, I wish I could turn it. I don't think I can. Hold on. Okay, fine. This is this. Oh, there it was. We can send you this way. Nope. There we go. Okay, so, geez Louise. Thank you. Boop. Boop. Yep. I just want to type from you. That's all I want. That's all I want. Okay. I won't label the axis. My bad, computer. Jeez. Nope, that's not it. It closed on me. I made it so mad that it closed. Hold on. Let me pause you. Okay, I got it back up. Oh, I didn't save it. Okay, so this was, so help me. I just want to type. Boop. Okay. This was car A. This was car B. Okay, anyways. So, where it seems to be going faster. All right. So, when something is this, so where is the slope steeper? So pretend that you are a little ant. Sure. Pretend you're a little ant and you're crawling up these lines. Okay, so if you're crawling up line A, you're crawling up a constant, whatever. You're crawling up a constant hill. Okay, it's the same incline the entire way up the hill. All right, so if you're a little, or we'll just be hikers. There we go. We'll be people. You're hiking up this hill, and so it's the same incline the entire way up. Okay? Whereas B, so if you're a hiker on B, you start out here. Ooh, it's nice and flat. All right, we're getting a little steep, but not crazy yet. We're getting a little steep. So then you're trying to figure out, just eyeballing, when does this one look like it's steeper than that one? All right. So for me, I'm hiking. Okay, we're getting a little steep here. We're getting a little steep. All right, and then all of a sudden, not all of a sudden, then I feel like, all right, right about here, maybe. That's what I would say. Yeah, I feel like right here, it like B gets steeper. Okay, so you're hiking up this hill, and then it gets steeper on you. So I would say from like, so that's steepness is how fast they're going. That's their slope. So until then, I think A is the faster car, A has the steeper slope. So that's from 0 to, shoot, now I don't know where, oh, it was right here. What is that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. So I would say from, wrong thing, from x equals 0 to 6, and I'm going to use a parenthesis because when I get to 6, I think that's when car B starts going faster. I think that's when car B gets steeper. But yours can be a little bit different than mine. Okay, you're just eyeballing it. So I think from 0 to, let me see if I can put a line right there so we can see it better. Okay, so I think it's at 1, 2, 3, 4, 5, 6. Right there. Come here, little line. Boom. So I think after that, I think that B is steeper than A. That means I think it's increasing faster. So if I'm a hiker, I think all of a sudden hiking up B got harder than hiking up A. All right. So that's why I use a parenthesis, because as soon as I get to 6, it switches. So then the next question, can I not write in the middle? Okay. Wow. There we go. Okay. Oh, so just the opposite question. When do you think B is faster than car A? So once again, you're a hiker. When is B steeper than A? I think this is when B gets steeper than A. You're just eyeballing it. So you're right. Remember, you're a little hiker and you're hiking up, and I think the B is steeper. You could be figuring this out mathematically. You could be like picking points and figuring out the slope. Right now, I'm just eyeballing it. So I would say from 6, and then from then on, like now B is definitely steeper, right? Like this. Here, let's move my line to like here. All right. Now B is definitely steeper, right? You'd rather be hiking up this than all of a sudden you're going up pretty fast on B. All right. So I'm going to say from 6, and then it goes on forever, so to infinity. You would use the infinity symbol, though. I just don't have that on here. And then whenever you use infinity, you use a parenthesis because you never actually get to infinity. So you have to use a parenthesis. You use brackets when that's in your interval, it's part of it. You use, this is going to come up with domain range too. You use parentheses for infinity because you never actually get to infinity. Use them for holes on your graph, and you use them for when you're approaching a number. So like this one, I'm approaching 6, but then as soon as I hit 6, I think the other car is going faster. So that's why it's a parenthesis here and it's a bracket here. All right. What in the graph indicates the speed of the cars? Oh, I've been talking about that. It's the slope. Slope, or you can call it the rate of change. So A has a constant rate of change and B's is changing because B is an exponential. Okay, number 12. A third car is now shown in the graph. All 3 cars have the same destination. If the destination is a distance of 12 units, which car will arrive first? Okay, so remember, down here is time, all right, and then here is distance. So a distance of 12 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I think it's this one. Oh, that's 12. Which car gets to that one first? Let me draw a line. Some of you, if you understand this, that's the beauty of video, you can skip through me. I won't be offended because I'll never know. Okay, that's pretty straight. So we're going to put that on 12. Oh, it's not long enough. There, okay. So which car gets there first? So that's where we're going, is we're getting to 12. This is the finish line. So which graph finishes first? Okay, well, A is not, if we extend the A line, it's not going to hit it until way over here. All right, here. Let me draw another line. I'm going to get so good at this. All right, I don't know if I can. Sure. Okay, so if we extend the A line, it's not going to hit it till way over here. Remember, this is time. So this is, maybe this is 14 seconds. So it's not going to hit it until like 18 seconds. All right, so A's out of the game. It's either B or C. So B, that's your exponential one. No. Okay, so this is B. All right, so B hits it. Kind of run together. All right, B hits it right there. See where the B line crosses it? And then the C line crosses it right there. Ooh, so it's close. But remember, now you're looking at time. So it looks like the C graph passes it just a little bit before. Just a little bit before. Right, now what if I can zoom in on just that part? Probably not. Let's see what happens. Oh, kind of. Zooming in, zooming in. Oh yeah. Oh yeah, that's better. Okay. So this is B, this is C. So C crosses it just a little bit before. Just a little bit before. All right, so C is your answer. And then justify your answer. Oh. What do you mean predict? We can tell. All right, so C arrives first. Jeez. Reset. C. Okay. Because you can look at the graph. Because when you look at the graph, C reaches 12 units per. Okay. Whew. That was a pain. Here we go. Domain and range. Oh, I had notes up here, I thought. All right, so domain. You can also watch, I posted like a 4-minute video that I stole off of YouTube. You can also watch. So this is your set of X values. Range is your set of Y values. So for domain, you're looking left to right, like you're reading a book. Range, you're looking low to high. All right. So, and it says use interval notation. So we used interval notation when we wrote, this was interval notation. This was also interval notation. Also today in class when we were dealing with the hare and the tortoise, and they gave us like from 0 to 2, like they gave us intervals, that was also called interval notation. All right. So domain. So you're going to start with looking at your X values. Ignore the Y values. Domain doesn't care about the Y values, only the X. So what's my farthest left point? -1. See how there's nothing at -2? So my farthest left point is -1, and then I have a continuous graph, and my farthest right point is 1. So your domain, you would use brackets because there's not a hole. If there was a hole, like let's see, who has a hole? Oh, number 18. 18 has a hole. That means you are approaching that point, but you never actually get there. You would use a parenthesis. One more time. This is a hole. So you would use a parenthesis. You're approaching this point, but you never actually get there, so you would use a parenthesis. However, for these, there's no hole, you use brackets. So it's from x equals -1 to x equals 1. All right, we don't write the y values for domain. Domain is only the x. From -1 to 1. All right, and then the range. Now you got to switch. Range is thinking about y values. So, you always write from low to high. So my lowest y value, -1. Okay. Once again, it's not a hole, it's a filled in point, so you're going to use a bracket, -1. My highest y value. So remember, we're looking low to high. So lowest is -1, highest is 3. So that would be domain and range for number 13. We'll do 16 because that's going to be weird, but we'll just do 14, and then we'll jump around. So domain of 14. So 14, the domain, you're looking at the x values. Well, let's see. I have -1. Oh, I have this arrow. That means that this is continuing forever in that direction. Let me get my line. All right. That means I'm continuing forever that way. Forever and ever and ever and ever and ever. That's what the arrow means. This line is just going on forever. Okay, so that's going in the negative x direction, right? It's continuing forever in the negative x direction. So I'm going to use a parenthesis because I'm going to write, oops, my bad. That was my bad. I'm going to use a parenthesis, negative, and you would use the infinity sign, which is a sideways 8, but I don't have that on here. So negative infinity, 2, and then what's my, now let's look the other way, farthest right value. Okay, I also have an arrow, so that means it is also continuing forever in that direction. So it's negative infinity to positive infinity. All right, and then range. Now you're looking at the y values. So remember, now we're looking low to high. Low to high. Low to high. Okay, so my lowest point is -1. All right, so that's not a hole, it's a point, so I'm going to use a bracket, -1. And my highest y value. Okay, I have 2 arrows. They're both going up. I have 2 arrows going up. So that means my graph is forever increasing. It is forever increasing. So this is going from -1 to infinity. And once again, with infinity, use a parenthesis. Okay? Why is it not negative infinity to infinity? Because my arrows are pointing up. So they're forever increasing in the y direction. For the domain, it was negative infinity because this one is forever continuing into the negative x direction, right? If I were to draw this out, this would be like -3, -10, and they would still be going in the negative x direction. All right. These are all really funky ones. Try number 15 on your own. Okay, number 16, because I don't know if you've ever written the domain and range of a circle. Okay, so domain. So start at the farthest left point. So the farthest left, -4. If I were to draw a line, I don't know where my line went. Hold on, let me just make another one. Okay. Boop. Kind of a straight line. Okay, that should be good. Okay, I'm just gonna move my line from left to right. So nothing, nothing, nothing. Oh, I hit a point. So my farthest left point is -4. So I'll get rid of it now. Well, bam. That's -4. So my domain is, use a bracket. My bad, keep doing that. Oh my goodness, I am hungry. All right, that's -4. So x equals -4. That's that point. And then your farthest right. Oh, I should have kept my line. Okay. So I started here. I was going left to right. So that's the first point I hit. And then what's the last point I hit going left to right? This guy. Bam. So it's from x equals -4 to x equals 2. And once again, use a bracket. Oh, sorry, it's not lined up. -4 to 2. All right, and then range. Okay, now I'm done with this. Same idea, except now you're looking from low to high. All right, so what's my lowest point? Oh, okay. You can also draw another line. My lowest point is -2. So, oh, delete that. All right. So let's put a bracket. Boom. My lowest point is -2. My highest point, So now we're going from low to high. My highest point is right here, which is 2. Bracket. All right. That would be domain and range of number 16. Number 17, I'm going to let you give it a shot. Number 18, you have a hole, so make sure when you're writing it, you use a parenthesis for the hole. Ooh. Okay, this is the only one that is not continuous. Think back to IM1. This graph is called discrete. Discrete. All right, this is a discrete graph. Discrete. Okay, not every x value has a y value. So like I have this point, -5, or sorry, -1 and -5, and then I don't have anything. All right, not every x value has a y value. They're not all connected. This is a discrete graph. When you write the domain of a discrete graph, you just list the points. So I'm going to use a bracket. I'm just going to list my points from low to high. So remember, domain is x values. So what's my lowest, sorry, my farthest left point? My farthest left point is -1. So my domain is x equals -1. And then 0, x equals 0. Then x equals 1. Oh, here, let me, look, I'll grab another line. Okay, that was a really long line. Oh my. All right, so that's x equals -1. And then we have this point at x equals 0. And then when x is 1, we have a point. So we have to add that onto our domain. 1. And then keep moving it. When x is 2, that's on our graph. And when x is 3, that's on our graph. All right. I'm not going to delete it because I might use it again. Who knows? Move it over there. So then we also have 2, x equals 2, and 3. And bracket, and you're done. That's all the points in your domain. So what's the difference? The difference is on all our continuous graphs, on all our continuous graphs, they also cover the fractions and the decimals and everything in between. So like I have when x is -1, y is also -1. Okay. When x is 0, y is 1. But also, when x is -0.5, that's on my graph. When x is, I don't know, -0.75, that's on my graph. When x is 0, it's 1. When x is 0.5, that's on my graph. Okay, so continuous means everything is covered. So everything between x equals -1 and x equals 1 is on there. All those decimals are in there. -0.8, -0.3, 0.7, all of them. They're all on the graph. They're all covered by this continuous line. However, when it's discrete, it's only the whole numbers, right? There are no fractions here. It's only these values. So that's why you write it. You just list the values. So range, I'm not going to do it for you. You do the range. But same thing. You're just going to list all of the y values like we did with the x values. Okay. I think I'm going to leave you there. I think I am. Yeah. No, I'll do the domain of number 18, but then you have to do the range by yourself. All right. So, oh, this is a weird one. Okay, so I'm looking at my x values first. So my furthest left point is just 2. The only x value on this graph is 2. That's so weird. I don't even know how you write that. I would just want to write that x equals 2. Let me see how they write it. Or you could put a 2 inside the bracket, but that seems silly. Let me see how they want you to do it. I would just want to write x equals 2. Oh, I guess I could have paused. Oh, well. Almost there. They do. They use a bracket. So they say their domain is just 2. You could also just write x equals 2. Right, because that's your only x value on this graph. X is 2. That's it. Okay. You don't need to worry about this whole until you get to the range. Oh, I was going to make you do the range. Okay, I'll just do the range. So then your range is low to high, right? So my lowest point is, geez, they split it up into fractions. It's just unnecessary. Okay, let's see. 1, 2, 3, 4, 5. Okay. So that is, hold on, let me pause you. I'm going to try and label this graph so it's easier to see. I was only slightly helpful. This is just overly obnoxious of them. I don't know why they felt they had to do this. Okay, so this red line, that's 1. Okay, so you're actually going up. This is 2/5, 4/5. So then 1 is 5/5, right? 5 over 5 is 1. So each line, so they're going up by 2/5. So 2/5, 4/5, 6/5. 8/5. That's still gonna check out. I thought I had it. Okay, well, 2/5, 4/5, 6/5. Oh no, that works. 8/5 and then 10/5, which is 2. Okay, yeah. They're going up by 2/5. That's very unnecessary. Okay. Okay, I'm glad I'm doing this one. So your range, my lowest point is 2/5 because 2/5, and then my highest point. Okay, here we go. Highest point is 6. But there's a hole there. So you put a parenthesis. I'm really mad about that. That's just overly obnoxious of them to do. Anyways, there you go. The rest of them you have to do on your own. Woo! That was a long homework help. Good job. All right. Bye.